All right, section 1.2 is going to introduce several new terms. So we're going to learn yet more statistics vocabulary. And the first thing they're going to ask us is a given value a statistic or a parameter? And this is a very simple idea. The idea is this. If we have a group of people, we call that a population. Now, within that population, this is the whole theme of the class, is I have a population. Let's say we're talking about America, 300 million people running around. I want to know lots of things about that population. I want to know how big they are, how much money they make, how they spend their time, all these different things. So that's my goal, is to learn about my population. However, will we ever be able to talk to and figure out the entire population? No. I mean, we actually do try to with the census every 10 years, but there's controversy there because we actually did the math in one of my classes. We looked at how many people died in a year, how many people are born in a year, and if you do the math, this country changes as far as people dying and being born by about 7,000 humans a day. Okay, so in 10, the census takes about 2 years to complete. So in that 2 years, 7,000 people changing a day, guess what? Your whole country looks different now. Okay? So very, very difficult to do this. So what do? We take samples. We take samples. And that's the whole point of this class, is statistics is to teach you how to sample so that you can get good answers about your population. And there's not a single business in the world that doesn't do this. So if you are planning to go into business, you will have to do this. You'll have to figure out things about your customers. And your customers will then be your sample. So if I take a sample of something, any value associated with this sample is called a statistic. If I have numbers for the population, although rare, but if somehow I got them, we call that a parameter. And guess what? It's very simple to remember, right? Populations have parameters, samples have statistics. So our letters match up. So let's look at the first problem. A sample of professors is selected and is found that 25% own a television. Well, they gave us the answer right away. It's a sample, so this 25% is a statistic. That's exactly right. So the ones that say parameter we can throw out. Statistic, because the value is a numerical measurement describing a characteristic of a sample. That's correct. The last one's incorrect because it says that it's a characteristic describing a population. So that's why that one's wrong. Take a look at 12. What would you say the answer to that one is? This is just a little bit trickier. Homeowner measured the voltage supplied to his home on 283 days of a given year, and the average or mean value is 109.2 volts. So we have to ask ourselves, is 283 days of a year the entire population for the year?
No.
Yeah, that's why it's tricky. The population for a year would be what? 365 days, not assuming a leap year. Okay? So in this case, this is a sample of days. And once we know that, then we can correctly answer that this is a statistic. So these two parameter ones are gone. Given value is a statistic for the year because the data collected represent a sample. Yep, that's right. How about 13? In a study of all 3,743 students at a college, it is found that 45% own a television. What's the key word here that makes you think that?
All.
Perfect. That's exactly what you want to hone in on, is that word all indicates that this is a population, and therefore this number is a parameter. So we would get rid of the statistic ones. Parameter because the value is numerical measurement describing characteristics of a sample. These two words do not jive. So sample, no, it's got to be this one. Let's make sure. Parameter, characteristic, population. Yep. Students tend to get these right on the test pretty consistently. I think they're pretty straightforward, right? Good. More vocab words. So we're going to introduce the idea of our data being either discrete or continuous. And discrete numbers are finite numbers. Typically, not always, but typically whole numbers. This is discrete. Continuous, you can have an infinite number of numbers, and these typically have a decimal. Again, not always, but typically that's a giveaway. So for an example, discrete would be like if I counted how many people are in this room. I have to have a whole number, right? Because I can't land on, there's 23.5 of you. Also, it's finite, right? There's only so many human beings we can pack into this room. So I'm not going to be able to just keep filling it up. Continuous, a very common way to explain this would be like measuring milk. Okay, so I can measure out half a cup of milk. And then if I get a better measuring device, I can say that's not half a cup, that's 0.52 cups. And I get an even better measuring device and say it's not 0.52 cups, it's 0.5234 cups. Do you see where I'm going with this? You can actually have an infinite number of measurements for just that simple cup of milk, depending on how accurate your measuring device is. So you could have 0.5, 0.52, 0.53, 0.504. There's a million different, more than a million. There's an infinite number of measurements you could have. Okay, so let's take a look at this. In an election poll, Svetlana received 17,380,866 votes. Now, don't be too concerned about yeah, it's a big number. Don't worry about the size of the number. Let's ask ourselves, could we ever have votes that are decimal values?
No.
No, so we're never going to have half a vote or a third of a vote. So these would only be discrete numbers. Notice again, it's going to be finite. She can only get as many votes as there are voters, which is clearly not an infinite possibility. So continuous are gone. Discrete, because there are a finite number of possible values. That's correct. Okay, how about for 15? The movie ratings of a critic with possible ratings being 0 stars, half a star, 1 star, and so on up to 5 stars. Would this be a continuous data set or discrete? So the critic only has these options: 0, half a star, 1 star, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5. That's the entire possible sample set that this critic can write. Is it finite?
Yeah, it's actually finite.
Yeah, I stopped writing. So if it was infinite, I would never stop writing. I would just keep
And just keep going.
These are all the options this critic has to write down. But I wrote them all down. So this is definitely finite. Don't let these fractions fool you. I see where you're going with this. If they said the critic could write any number between 0 and 5, like he could say, he or she could say, I give this movie 3.12 stars, then you would be right. Okay, so because it's finite, these are the only options he has. This is discrete. So we get rid of the continuous ones. Discrete because the data can take on any value in an interval. No, we said that it can't. Discrete because the data can only take on specific values. So there's only these 10 options or whatever the options are, however many you count there. Questions on finite or discrete? Or excuse me, finite or discrete or continuous? So that's typically what you want to ask yourself is, could I write numbers forever, or is it infinite, or is it finite? And then that'll help you determine the right answer. Okay, 16 will contain, I think, the last vocab we need to learn for this section. So determine which of the 4 levels of measurement, nominal, ordinal, interval, ratio, is most appropriate for the data below. Nominal means there's no order that you can put the objects into. So think I'm trying to arrange flowers, right? The way I arrange the flowers might be completely different than the way you arrange the flowers. Why? Because there's no set convention of order, right? I don't know what order I can put them into. I mean, you might say something like alphabetical order based on their names, but then if you convert their names to Spanish, now the whole order would change, right? So let's think arranging flowers here. There's no set convention on how to order them. Ordinal, it's in the name, does have order. So let's think in this case, jersey numbers. So if I want to get a photo of my football team, and I think it might be clever to have all the players in order based on jersey number, I can quickly tell my players, okay, get in jersey order number, and they will have very little confusion doing that, right? They'll all be able to quickly get into the order. Interval, this has order, and you can perform some math on it. So you can perform addition and subtraction. This is where the jersey numbers doesn't make sense. So if I take my jersey number 10 and subtract from him jersey number 5, that's a bad given. If I take jersey number 10 and I subtract from him jersey number 6, does that equal jersey player 4? Mathematically it equals, right? But how do I subtract 2 human beings, and how do I say that the subtraction of 2 human beings is equal to another human being? You see how this breaks down? So this would be now more like measurements. So weight might be a good example. So in weight, I can say person A weighed this many pounds, and then 10 days later they weighed this many pounds. If I subtract those 2 numbers, I get a valuable piece of information. I know how much weight they lost. And we can also order people based on weight or height. We could say, okay, everyone get in height order, and you'd see the people, getting into the right order. And we can subtract their heights and get the height difference. Last one, ratio. This has order, and it has all the math that we could want to do on it. So addition, subtraction, multiplication, and division. So classic examples would be money, one of our favorite topics in this class. So I can add money, subtract money. I can say if I doubled my money, that's very important to me. I can say if I halved my money, that's very important to me. So all those different mathematics are now available to me. Question?
Are we gonna, like, with the ratio, are we gonna talk about like the inherent zero at all?
Yeah, yeah, so in these other measurements, what she's mentioning is an inherent zero. So that's this idea of, is there a zero in the system and does it matter? Okay. I think for my course, I never truly really asked you about that or require you to know that. So let's try to keep it a little simpler. So we'll just go with my definition here. So I don't want you to think too much about, does the numbering system have a zero in it? Okay, so let's look at this one then. So determine which one this is. Companies that produced movies in 2007. So we start with, the first question you should always ask in problems like this is, can there be order? So you ask, how would I order these companies? What's that? Okay, so you could order them by number of movies produced. That would be one way. Is there
do it
another?
by the month they came out, or they produced it?
You could do that. Yep, you could put some kind of time measurement on it. Any other ways? How about alphabetical based on the company name? How about, or maybe, did someone mention this, the year they were created? Is that what you said? Or, no, I think someone said how many movies they produced, right? But you could do year the company was created. You could do alphabetical based on their name. If I don't have one that's really clear and we all agree on right away, then I don't have any. So because we could sit here and word game this and really come up with a big list, but there's no clear one that is clearly the winner, then we say this has no order. So it's nominal. Yep. And I think the only one that mentions the word nominal is D. And this is again where in statistics, I'm going to try to get you not to overthink it. Okay. Determine which of the 4 levels of measurement, nominal, ordinal, interval, ratio, is most appropriate. Monthly temperatures. So I think we could clearly all put these in order, right? So all I need to do is have just a little bit more information. I might have to say smallest to biggest or biggest to smallest, but if I said that, you would all very quickly get the right answer. So there is order here, which means nominal's gone. We know there's order, so this one works, but let's see if the next one works. Would interval work? Which is to say, if I add or subtract temperatures, does it give me any information that's valuable? And before you answer, let me put it this way. If I tell you that tomorrow is going to be today's temperature minus 50 degrees, is that important information for you?
Yeah.
I would say, because now you can make very useful decisions based on that small piece of information. And all I did was use subtraction. So I would argue that this is also interval. Now let's go to ratio. Ratio would have to be addition, subtraction, multiplication, and division. If I divide 79 degrees by 75 degrees and I get the number 1.03, does that number have any value to us?
No.
Not really. So we're going to say this is not ratio. So the best we got was, the furthest we got along this one was interval, so that's what we're going to say. I want you to look at 18 and think about it. Maybe even socially distance-minded, talk to your neighbor and see what you come up with. Does anyone want to boldly give us their logic, how they approached it? So let me rewrite our list. Nominal, ordinal, interval, ratio. And as I go down, I can do more math. So first, let's discuss nominal. Can I put these internet speeds in order if I have the numbers 100, 200, and 300? Yes. So nominal says there's no order, but this one says there is an order I can put them in, so let's cross him off. Ordinal says I can put them in order. We just agreed that that could be done. Interval. Interval would mean I can subtract these numbers and get a meaningful, add or subtract these numbers and get a meaningful result. If I add the slow speed and the medium speed, the numbers equal 300, but does the speed equal fast? If you think very carefully about this, there is no way to say that that's true. Okay? So I would argue you can't do interval. If you can't do interval, you can't do ratio. So this is ordinal, and this is where this one's a little tricky, is that yes, you can put them in order, but you can't truly do interval, which is what you might have wanted to jump to. Okay, what is wrong with the given calculation? So they added up all these 710 different internet speeds and divided by 710, that's how you take an average, add up all your numbers and divide by how many numbers you have, and they got the speeds are 231.2. A says the true average is 195.4. Well, how do we know that? Without taking the 710 numbers ourselves and doing that calculation, I can't disprove this number. So A is out.
There's really no way of proving.
What's that?
There's really no way of proving the average. I mean, you don't have enough information to put it in.
That's true. That's true too. Yeah. Without seeing these 710 speeds, I can't even, I have to take their word for it. Okay, one must use a different method to take the average of such data. Well, we're assuming that they just added them up and divided by 710. There's nothing tricky about that. So, but again, they didn't tell us the method. So I can't say this either, because I assume I know how they did it, but they didn't say how they did it, so I'm not sure either here. Such data should not be used for calculating such an average. That's really the answer. They are performing a division, right? Average is this. You add up all the numbers, and then you divide by the number of numbers. But this is a division. And you can only use division on ratio values. Well, we already said it's not a ratio. So you cannot perform an average on, you can't perform an average on any of these three types of data. So C is the best answer. There's nothing wrong with the given calculation. No, there definitely is. And honestly, this is a bad system anyway. This is pretty close to the stars for movies, right? Who decided that the slow speed should be 100 and medium should be 200 and fast? They could have called this anything. That's why when you shop for internet, what do you actually care about?
RPM.
Yeah, you care about megabits per second. So if they had said this is 100 megabits per second or 200 megabits per second, etc., then all of that goes into ratio. Because you can perform all the math you want on these numbers. You can perform divisions and multiplications and all those things. Because they have a unit. People know what megabits per second is. This one, and that's why this one's tricky too, because if you assume that these are megabit per second numbers, then this whole problem breaks down, and it doesn't work. Okay, 19. Which of the following is associated with a parameter? What was our key word with parameter? Population. So those two words are intertwined. So data from a sample, no. Characteristic sample, no. For the entire population, that looks good. Data obtained from a volunteer poll at the end of a service call. We've never even talked about a service call before in this class. So C. Last one for today. Don't let me forget to take attendance before you all run out. Which level of measurement consists of categories only where data cannot be arranged in an ordering scheme? There was only one where we could have no order. Nominal. Questions? Hopefully this is feeling pretty nice and easy. That's the way we like it.